Good evening, everyone. Hi. Good evening. My name is Boaz Golani. I'm a professor of industrial engineering and management here at the Technion, and in recent years I'm serving as the Vice President for External Relations and Resource Development. It's my great pleasure to greet you all here on behalf of the Technion management to this panel discussion entitled Israel in Space, which is held here as part of a special summer program of the International Space University 2016. I guess some of you would expect me to refer specifically to the unique role that Israel has been playing in space since the 1960s, and much more importantly, since it started launching satellites into space in the 1980s. But I will leave that part to our distinguished panelists, and I'm sure they will do a good job about that. Instead, I'll focus on an important dimension that characterizes much of what you see today in Israel, and that is entrepreneurship and innovation. Known as the startup nation, Israel boasts more patents per capita, more research papers per capita, and more startups per capita than any other nation on the face of the earth. Here at the Technion, we are proud to be the cradle that generates much of the technology innovation that attracts global media attention as well as an ever-increasing stream of investments. This entrepreneurship feature has already created an impact in our space industry with dozens of small companies that specialize in communications, composite materials, vision, and other components needed in space. Israel is too small to ever create an agency that will compete with NASA, or companies that will compete successfully with the likes of Boeing or Lockheed Martin. But we are quick, agile, and have the chutzpah, which is the nerve, to develop innovative new devices, components, sensors, and in some cases even systems that can compete well in the global arena. I certainly hope that hosting the ISU 2016 will drive more young Israelis to explore new horizons along these lines. I wish us all an interesting discussion and look forward to hearing the panelists. Thank you very much.
On miniaturization and developing national capabilities in the area of lightweight small satellites of high resolution, remote sensing and communications, a field in which it is acknowledged as a world leader. Based on this technological know-how, Israel expanded its national space expertise, developing commercial satellites. Israel's insistence on maintaining ability to design, build, and test and launch its own satellites has led to an advanced engineering achievement and the startup mentality with regards to space technologies. An overview of Israeli space assets is in front of you. Currently, several Israeli groups are developing microsatellites and nanosatellites for demonstrating and validating new technologies and technology spin-offs. An additional outcome of all of these activities is educational public outreach, inspiring young people to pursue their futures in the business of space. So the Israel in Space panel will present all aspects of space in Israel with representatives from the government, academia, industry, and startups. I will now introduce our speakers and invite them each by each to the stage. First, I am honored to invite Director General Avi Blasberger, the Director General of Israel Space Agency, Ministry of Science, Technology and Space. Avi is a mechanical engineer. Before joining the Space Agency, he was a VP at Elbit Systems Electro-Optics until 2014. Since then, he consulted to Samuel Neeman Institute and served as the Secretary of the Space Committee of the National Council for Research and Development. During that period, he also studied for a PhD in astrophysics here at the Technion. Avi, please. I am proud to present Amnon Harari. Brigadier General retired Amnon Harari is currently the head of Space Programs Directorate of Defense R&D at Israel's Ministry of Defense. Amnon retired from his military service in the Israeli Air Force in '97, where his last position was the head of the Israeli Air Force Material Directorate, which is the organization responsible for all research, development, acquisition, maintenance, logistics, and control. After retirement and prior to his return to the defense arena, Amnon held various positions in the industry. Apart from that, General Harari is also a former chairman of the Israeli Gliding Association and an active pilot instructor. Amnon, please. It is my pleasure to invite Professor Pini Gurfil, the director of the Asher Space Research Center at the Technion and the host institute for this program. He holds a PhD in aerospace engineering from the Technion. Professor Gurfil has also been with the Department of Mechanical and Aerospace Engineering at Princeton University. Professor Gurfil has been conducting research in astrodynamics, distributed space systems, and vision-aided navigation. He is a corresponding member of the International Academy of Astronautics and Associated Fellow with the American Institute of Aeronautics and Astronautics. Professor Gurfil is also the PI of Technion's Samson satellite project and a winner of the prestigious ERC grant. Please. Professor Avishai Galyam is a professor at the Department of Particle Physics and Astrophysics at the Weizmann Institute of Science. Before he joined the faculty at Weizmann, he graduated from Tel Aviv University and spent 4 years as a NASA Hubble postdoctoral fellow at Caltech. His main topic of research is time-variable astrophysical phenomena, and in particular, exploding stars or supernova. Please. From the industry, we have Ofer Doron, which assumed the job of General Manager of MBT Space Division of IAI 5 years ago. Ofer served in the Israeli Navy from '79 in command and staff posts. He commanded several missile boats, including a SAR-5 corvette and squadron. His last position was head of the Operational Requirements Department. Ofer retired from the Navy as a captain in '02 and still serves in the reserves. From '03 till '08, Ofer was the director of marketing for MBT missiles and afterwards headed the Tactical Systems Division at NES. Ofer, please. I am especially proud to present Dr. Nili Mandelblit, a co-student at the program. Nili is the Director of Space Transport and Nanotechnology Materials Programs in ISU, the Israel-Europe R&D Directorate. In her role, Nili serves as the head delegate of the Israeli government to the European Commission Space Research Program Committee. In addition, Nili is a member in the Space Committee of the Israel National R&D Council. She holds a BSc in Computer Science from the Hebrew University and a PhD in Cognitive Science from the University of California. Nili also conducted a career in the high-tech industry in Israel in a number of international software companies. Nili, please. Last, but definitely not least, Ofer Lapid. Ofer holds a BSc in Electrical Engineering and MSc in Electronic Systems Engineering and Management from Tel Aviv University. He's an alum, faculty, and trustee of the International Space University, representing the Israel Space Agency. Ofer has over 25 years of experience in aerospace and space program management and technology development. Ofer was appointed to the specialized panel of scientific experts pursuant to the Permanent Court of Arbitration Outer Space Rules since 2016. Currently, Ofer is the program manager of Ultrasat, astrophysical observation satellite at the Weizmann Institute of Science in collaboration with Caltech and JPL, an expert evaluator of the Space Technologies R&D program for the Israel Innovation Authority, Israel Space Agency. He is the co-founder and CTO of SpaceNest, an Israeli space startup incubator. Ofer volunteers as a mentor for SpaceIL, the Israeli Google X Prize lunar lander mission. Ofer, please. Okay, and with that we begin. And I would like to start by asking Avi and Ofer Doron, what are the primary achievements of Israel space science and technology, and what role Israel plays in global space activity? Avi, please.
He said that Israel is specialized in small satellite. We have various constraints when we started in the space activity, and therefore we found our niche in space in small satellite, in which I think in terms of weight to performance, Israel is the leading country in the world in that. In terms of science, it's also from our decision where to go in the beginning. Israel is specialized in remote sensing in terms of the academy and of course in utilization of remote sensing imaging. In terms of science or pure science, Israel is one of the leading countries in astrophysics, and I'm sure that Avishai will elaborate on that more than me.
Ofer?
I think first and foremost, we've shown that when you really want to, and when you really have to, you can do the impossible. So we're the first small country that's actually made it to space, to build the satellites and to launch them. And in fact, we're the only small country that's in that family up to now. The next largest country up from us is Iran, which launched satellites, and they're dinky ones. And the second thing we've managed to do is make them very, very serious satellites. So whilst we were very, very small compared to other serious satellites, they're big in performance. So the next ones we're putting up quite soon are going to be giving images with about 40 centimeter resolution, and they weigh less than 400 kilograms. That's about a fifth of the weight of what a normal imaging satellite that provides 40 centimeter resolution weighs. And it's down there in the price as well. So, and that comes from being forced to do it. And it's probably one of the best lessons we've had in our space program. Innovation comes from limitations, and when you have big problems, you have to solve them within boundaries and limitations. You make a big step forward, and it's been an interesting experience.
Thank you. Pini, Avishai, and Nili, can you identify, please, the emerging directions of space science and space technologies in the coming years, and what are the opportunities for Israel? Pini.
In terms of engineering, definitely building small satellites, nano satellites sound trivial, but it's the emerging market today. It's giving opportunities to academia and to government institutions alike to break the boundaries of cost and launch. This is a very important trend. I think that beyond that, we have diffraction limited optics, building telescopes in space that would see farther. give us better resolution images, especially exoplanets, which I think is the holy grail of engineering and science, is to actually get an image of an exoplanet. We have technologies that are waiting to be tested in space, such as quantum communications. So I think that would probably be an important direction. Building new propulsion systems that are more efficient, especially electric propulsion, with emphasis on miniaturized electric propulsion systems that would enable us to actually launch nanosatellites that can do something in space. And of course, all the aspects related to space exploration, human spaceflight approach to Mars, and sample and return missions.
In terms of science, pure science usually have smaller budgets compared to commercial applications. So the challenge is always, especially for a nation like Israel, to do forefront science with relatively small budgets. And I think the sort of special capabilities that have been developed, and as explained by the previous speakers, are especially relevant for that. And indeed, we are now working on several missions. The Ultrasat, which you mentioned, is one of them, that will be able to do something much better than done by much larger, more expensive missions, using smart use of new technologies. And I think this is going to be the way forward.
by the government budgets and how big it could get, and it's suddenly growing. It's growing because there's money coming in, it's growing because there are new clients coming in, it's growing because there's new industry, and it's getting everyone excited. Many of the people in these startups have grown up around the industry, some in the larger industries like at IAI, some inside the defense forces where they dealt with satellites, and others on other fringes of the industry. So there's a movement of people going back and forth between the places. It's causing a lot of buzz and a lot of innovation because suddenly big industry is taking a look and saying, these guys are doing things differently. We got to wake up, we've got to think faster, do it cheaper, and get younger again, because we're sort of getting a bit old and heavy. So it's moving us all in unexpected ways, and I think it's probably the best thing that's happening to our space industry right now, and in the overall view.
Thank you. Avi, what is the role of Israel Space Agency in the atmosphere of the new space in Israel?
I think the offer already mentioned this role of the government. Mainly the government have to support this process and to encourage this process that it will increase. So the support of government is usually coming by money, and the government is supporting these new companies with money, with investment. It's not an investment actually, it's a support. And encouraging the process to happen. And the encouragement is also encouraging the companies to work together with the academy, because some of the ideas are coming from the industry, but some of the knowledge exists in the academy. So the role of the government is to do the cooperation between academy and the industry, and to support the good ideas with seed money that it can start the startup.
Neely, would you like to add something from the perspective of ISU and the Ministry of Economics?
Wonderful ways that the government can support new entrants to the market in the new space. There is another angle for that, and that's for how the government can reduce barriers to new entrants in terms of regulation. And one of the prime examples in Israel, but also everywhere in the world, is export control. I experience it a lot with small companies that I work with. When they have to apply to an export license, they have to wait for a long time. And through this time, they cannot talk to partners, to international partners. They cannot talk to investors. And for small companies, this could be a death blow. So I think the government should also think about how to make maybe special procedures for export control and also other areas to have this faster and easier and more transparent when it comes to new entrants, small companies in space.
Thank you for putting that in. Ramon, what can the military space activity in Israel can benefit from new space activity?
Well, first I would like to say that we are talking to the future. We are mentioning here new space. We don't know what new space is. It's a buzzword, it's a headline. That's it, that it is. One thing I'm sure, most of the companies, the startup that starts today on new space will not be there. It's not a guess. It's what's happened in any new attractive trend that is in the industry. From those companies that will survive, their business model will change. Today they think that they are going to develop hardware or service. Tomorrow, in order for surviving, they will change the business model. They will change everything. Okay, so it's very difficult to assess what will happen, and we are talking about the future. Some obvious things will happen. If money will be pulled into developing technologies, they will be there. So there will be new components, new hardware pieces that one will be able to buy, maybe buy cheaper because it's done not in a regular way, but that will happen. I'm almost sure about that. So the question that we in the military ask ourselves, what are we going to do with that, with the new space that we don't know what will happen with it? And obviously, when we engage with the industry, we must ensure that we have a long-term engagement. Okay, so we need to engage only with those companies or technologies or whatever that will survive for a long time. And now, basically, three options that one can apply. The first one is just wait and see. Okay, that's the easiest one. Wait and see the market will develop with hardware or with services, and then if these hardware services fits us, we can contract and buy them. That's one way to do it. The other way is to say, hey, I'm the old space business, I want to lead, so let me lead the new space. It's an option. As a matter of fact, if I look at the history, this is what we've done 30 years ago. We had nothing, so we decided that our new space will be what we have here, and we saw the slide of Deganit earlier, and we were new space back then. We became a little older, okay? And the third option is we can try to influence, okay? Talk to these companies that are carrying the flag of new space. See what their intention, and see if we can influence. So apparently we do that. We don't promise anything, but we go and talk to the people, and we find out that they are thirsty to hear what we have to say. We, as a representative of the operational needs, okay, of real needs. By the way, if you look at what the Americans are doing, very similar. You have that, like an organization like the NGA. NGA leaders are talking to industry and say, hey, go ahead, develop, and we'll see what services or material you're building, and we'll encourage you. We don't invest money in you, but these are the directions that we think you have to follow. And if you'll be there, we may buy. And they listen, and they hear. And this is the way I think that militaries or governments should follow.
Thank you. Amnon, a downside of the growing global space activity is that space, and especially low Earth orbit, is becoming crowded. So this trend highlights the importance of assuring space remains a secure and sustainable environment. Can you tell us about the role Israel is playing keeping space a sustainable and secure environment?
Well, the Israeli case is pretty simple. First of all, we are flying low, okay?
In the wrong direction.
Yeah, wrong direction is, we are flying low, and we are flying low as much as possible. As long as the hardware works and we have no malfunctions, then we'll fly low until the satellite will disappear, entering the atmosphere. So we leave no debris. Also, we are not so big, so we launch few satellites, the numbers is negligible. And I guess that when we will be, let's say, a new space, and we will adopt the applications using nanosatellites, and they will fly maybe in higher altitude, higher heights, so they may be a long-term threat. I guess that what we'll do, we'll adapt the international standards of responsible space, and we'll make sure that we'll adhere to whatever the requirements are. Right now, people are talking about 25 years of duration of any man-made hardware in space. I guess we will have to take the measures to cope with that.
Thank you. Really continuing on this issue, Europe is also putting a lot of efforts in assuring that space remains safe and secure and sustainable. From your perspective, what are the major needs currently arising, and how Israeli industries can get involved?
Indeed, working with the EU, the European Union space policy, they recently added a third priority, a third objective to their space program, which is after the two main objectives of the EU, which the two main programs are the Copernicus Earth observation and the Galileo satellite navigation. And since 2012, a third objective has been added, which is the protection of the European space infrastructure. Now, this objective is currently running as a major initiative, which is called the SSP Space Surveillance and Tracking, where the EU is trying to develop their own system for identifying and monitoring spacecrafts and space debris, rather than being dependent on the US for that. This is one direction. But in addition, we also see a growing concern in Europe about the issue of cybersecurity. Europe in general has growing concern about attacks against critical infrastructure in Europe. And space being a critical infrastructure and being also a symbol of national power and pride could be a target for attacks. So we see a growing, let's say, concern and requests for solutions in cybersecurity. This is really still in very infant stages. I don't think even the requirements are known or can be defined. And this is an area where I think Israel could have a big contribution. Israel recently, the Prime Minister of Israel recently initiated a national space bureau in the Prime Minister office. And we are maybe considered already today, maybe the leaders or one of the leaders in cybersecurity. So this is an area where we could contribute, combining our capabilities in cybersecurity. I should mention also that I think within 2 years, the number of startups working on cybersecurity in Israel grew from few dozens to few hundreds today. So if we combine this with the space capabilities, this is a place where we can definitely have a contribution.
Thank you. And with that, I want to go back to science and ask Pini and Avisha if you can elaborate and better explain to us the achievements of space science activity in Ilan. If you can tell us more about it.
So let me start with describing a few of the things we're doing. When you're building small satellites, you have to compromise on something. Otherwise, if you don't compromise, you end up with something very large and very expensive, and that's already been done by other agencies. So one of the areas that is a focus of Israeli science for a long time, also observations from ground, and now in space, is variability. So looking for things that change, that are not constant, things that explode, things that appear and disappear in space. This requires surveillance, which is an area of space activity in Israel that is very well developed. And it requires looking at large patches of sky, which is a natural thing that is easier to do for small satellites with smaller optics that cover larger fields of view. So this is an area that is being developed. And there's a lot of discoveries being made already from the ground by pathfinder experiments using ground-based telescopes. But going to space is, of course, much better because you can have continuous view of space without interference from the day-night cycle, for example, that you always have on Earth. And so this is something we're working on very hard. And for me, the most exciting thing is I'm working specifically on exploding stars. So when you have a satellite in space, you can actually see the star explode in real time, not learn after actually the event happening while you're that's something that hasn't been yet. You can only do. Another thing, of course, that space allows you is to observe in wavelengths that are not accessible from the ground, in particular ultraviolet, and also to some degree infrared. So these are all areas that are being developed by different scientific reasons, which are very interesting.
Penny, would you like to add?
I assume that you meant technological achievements in academia and not in industry, right? So I have to mention that we launched in '98 one of the first student-built satellites that was launched from Kazakhstan. It's called the TechSat. It was a microsatellite. It was a 50-kilo satellite built by Technion students. It was a huge achievement back at the time, and actually it holds the world record for student-built satellites in terms of lifetime. It was operational for 13 years, although it was only planned for 4 years. In addition to that, there's a myriad of technological achievements in space. I should mention that now we're working on a cluster flight mission that would be the first mission to fly 3 autonomous nanosatellites, 6U each, that would do geolocation in space. So in terms of algorithms, in terms of the hardware, everything is being built at the Technion. In terms of technology, there are, I should mention a few other areas such as optics and propulsion. We are, I think, now in the process of finalizing a design of the most efficient Hall thruster in the world. It's called the Camilla Hall thruster. Hopefully it will fly on one of our future missions, so it's a huge achievement. So we have a very strong background in electric propulsion. In terms of other fields of science that are being investigated here at the Technion, so we have some, I think, very nice achievements in planetary sciences. There's a new published theory on the origin of the moon by a physics professor named Chagai Peretz. We have a very strong remote sensing group, civil engineering, who has been doing fabulous work in remote sensing, multi-spectral imaging, and I could go like this for another hour, but I will stop now.
Thank you. I want to ask you, both of you, and Avi as well, many spacefaring nations have targeted the moon and Mars, as well as other missions deeper into space for the future space exploration missions. Given Israel's specialization is it important that Israel will take part in this process, and if so, what part can it play in this trend? Who wants to start? Penny?
The answer is no.
The answer is no? Okay.
I think, well, let's distinguish between the moon and Mars. It's not the same. Let's ask the ISU students, does anyone think that the moon is an interesting target from the scientific viewpoint? Okay. Okay. Out of 100, it's not a lot. Mars is a different story, of course, and the other planets. But I think Israel has a tradition of innovation and breakthrough research, and of course it can contribute in terms of subsystems. But satellites is it's a whole other issue. And I would rather see Israel taking the lead in high-resolution optics in space and building mirrors for future space telescopes, rather than being a second violin for other nations' efforts, such as the European Space Agency and NASA, of course. As mentioned before,
would you say the same about our participation in the LHC, for example? We are not going to build such a, so participating part has a value.
This is Israeli space community.
It's you see, this is a genuine argument what you see now, so it's really, it wasn't planned. So as I said, in terms of subsystems, we have the Curiosity cooling system was built in Israel, right? That's perfectly fine. But in terms of strategic goals, I don't think that launching satellites to Mars or to the moon should be of interest, because we can never be the best. But we can be the best in other issues, in other directions. And this is what I think we should utilize.
please.
So, after all these heated arguments, one aspect I think is applicable to planetary science. Again, if you try to think about Israel not competing with very extremely well-established efforts by the larger space agencies, I think is perhaps autonomous operations of landers. If you think about the American space activity on Mars, for example, I think by far the most impressive, I'm not sure if it is the most scientifically important, I think it is, but that you can argue about, is the lander, the rover programs. And these are small, well, not autonomous, but semi-autonomous vehicles. And if you could make them as small and fully autonomous, then you can do something much less complicated, build many more of them, and do something different. Because there are parts on the face of Mars that are not accessible to the large agencies because they have to land with large spacecraft. So if, for example, if it's a steep slope, you cannot land because you will topple over. If you can land with something much smaller, which means that you have to be autonomous, that can open new possibilities. So we have to think out of the box. I agree with Pini that trying to build similar spacecraft to the ones that are already being built by the Americans and the Europeans is not productive. But maybe we can think about that.
So are we listening to them? What do you think?
I would like to take another point of view, not talking about the Mars or the Moon, but if Israel has to join a purely scientific mission. And the answer is yes, and not no. And the answer is that through scientific mission, first of all, you can enhance the multilateral or bilateral cooperation with other agencies, first of all. And secondly, you can do a small mission like the Weizmann Institute is proposing now together with NASA, or Technion is proposing together with NASA, or currently we are doing with the Italian Space Agency some small part for the Jupiter mission, and therefore we can join the science of this mission. I think Israel can join a scientific mission, and it is important that we will do that.
Okay, so again, offer and offer. When you listen to this dialogue here, what can you recommend for the future space entrepreneurs if they want to operate in Israel?
Come along, we'll help you.
So I have a slightly longer answer, but there was a request from the crowd for an Israeli space joke. So I'll make a small intermission. You know that we are launching all of our satellites westward. If you don't know, you should learn and do your homework. The reason we launch all of our satellites westward is that all of the engineers are Jewish and they are writing from right to left. Okay. All those who heard this for the first time raise their hand. Oh, that was okay. So that's for Ram Levy. Anyway, if you want to create a startup, first you need to have a market. Rest assured, the market is not in here. The market is overseas. It's in the US. Half of the space market is in the US. The other half is the rest of the world. So you have to have a partner who will get you the access to the market. The Israeli partner will be very good at fast prototyping, developing the cool stuff, because we are innovative, creative, impatient, and chutzpah, as I said before. We're strong on VLSI, physics, computer vision for autonomy. Think about Mobileye. We're very good at VLSI and physics. So you can get a lot of partners, a lot of employees in here. It will not be cheaper than Silicon Valley, but you'll get faster time to product, I guess. Funding is covered. The government will help you with up to 85% of your innovation costs. If you hold your development in Israel, you don't have to be an Israeli, but you have to live here. That's not too bad. I mean, you've seen the beach. And the best contribution of the Israeli part will be fast time to market. If you want to do mass production, like millions of satellites, I guess you better do that in China or somewhere where the production is cheaper. But we'll get you there faster. The last part is the product. You have to come with a killer product. And if you have a good idea, come to me later and I'll help you.
Okay, so thank you.
And when I said come and we'll help you, it's a specific offer to help you. Because one of the things space entrepreneurs, especially in the satellite domain, find very difficult is satellites are very multidisciplinary. So you start needing experts in everything, and then you have to build it, and then you have to test it. And that needs big infrastructure and a very diverse set of skill sets that you cannot find in a small startup. And it's one of the things we're working at with some of the startups that are evolving in Israel, is helping them with many of the different specific fields that aren't important to what they're trying to do, but they're important to build the spacecraft. So that's one of the places where the combination of big established industry with smart ideas from startups can bring a lot of added value, and we're trying to work on those things together within Space Nest.
Okay, so before we open for questions from the audience, all of you that sit here today, you sit here as leaders of space, of the space sector of Israel in your diverse fields. But down there sit the future leaders of Israel's space sector. What are your expectations from them, let's say 5, 10, 15 years from now? Where do you want to see Israel's space community at? This question is open to all of you. Who's brave enough?
Where do we want to see Israel in 15 years? Bigger and better. That's to start with. This is the reason we want to support the new space, to be in the top of the line of the product, with new product, and mainly also new services, because as it was mentioned here, services are the future from space, and services is also supporting the space industry, because to bring services from space, of course, you need the space. So we want to be far ahead in 15 years from now.
Hey, 15 years is a short-term plan. So the short-term plan is to be completely integrated in the international community. So we will be recognized for our merits, we will be recognized for our shortcomings. Nobody's perfect, but we have a lot of merits, and we are very good at cooperating with others. We are the eighth spacefaring nation, and we don't yet hold the 8th ranking in our space economy. So that should happen over 15 years, and we should focus on the things that we do good. Because maybe, and I predict that in 15 years, the satellites will look much like cell phones. They will be software defined, they will be very, very complex and very, very versatile. And these are things we do good. So yes, in 15 years we'll be much more integrated in the international community as productive partners.
I think I'd like to see a space industry that's a bit less government-centric and a bit less military-oriented, and there's a lot more civil space and commercial space inside it. It's a big challenge, and the only way to get there is if we work together with the startups and get new ideas out there. It's very, very difficult to get a strong commercial presence when you're sitting in Israel. It's far away from the center of attention for most customers. Ofer was speaking about the need to get partners, but I think it's a goal we have to strive for, and if we manage to get a more balanced space ecosystem in Israel, it'll be a big step forward.
Let me first make you a little bit more relaxed, okay? I'll take you back, I think, more than 40 years.
I joined the Israeli Air Force as a young officer, just graduated from the University of Tel Aviv, sorry about non-technion, you know. Yeah. And I joined our test range. We had a computer, only one. It was the only one computer in the Air Force in test range. We had radars, we had telemetry, we had everything. People were in Europe and America to purchase the stuff and came back here. And I was, what, 21? And I said, hey, they invented it. And there's nothing more to be invented. I was a little desperate, depressed in these early days. So now, let's take us back from the early 70s to now, and you see what kind of a development. One thing I can assure you, you cannot forecast. You cannot say what will happen in 15 or 20 years. But what will happen is good stuff. So if you people want to be part of it, it's a matter of a decision, personal decision. I want to be part of the space industry, and then you join and you go there. And I'll give you one example of an alumni of 2 years ago from the ISU. Okay, Michal. Yeah? She came to me. Michal. To me, presented her work together with some other students in the ISU of 2 years ago. And I looked at her and I said to myself, she has to work in space. So I called Ofer and took him maybe 1 year, I don't know, maybe less than 1 year, to get her through the channels and to be satellite engineer, which I think the best way to understand space. So she had the will, and she had the passion, and she wanted what she would, and she's now in space. What will happen with her or any other in 15 years is very difficult to predict, but this is what you people have to go. You have to decide that this is interesting, you want to be there, and to start your work. And then life will lead you to wherever it will. But the start is a matter of a decision of the young ones.
Was the question specific about Israeli students or?
Your
15 years? Well, if it's specific, then I would, in 15 years, expect to see physically an Israeli in space. Not in mind, but actually someone doing an EVA who is an Israeli, for example. And the reason is not romantic. It's because the single astronaut we had just revolutionized the way that we treat and educate our students about space. So hopefully that will happen again. And as opposed to the government, we're in academia, we're not trying to predict the future, we're trying to invent it. So I think Avishai would agree that we are looking into directions that now are a little bit problematic or dubious, but we are trying to get there. So any student who has a far-reaching vision and a crazy idea, that would be technically would be a good place to start. No one has mentioned the issue of launchers. I think that currently there's been some words here about nanosatellites, small satellites. Currently we cannot launch nanosatellites independently. We are dependent on other partners, which is really a huge problem for academia because we cannot afford it, and that kind of limits what we can do in space. So real space visionaries can actually see the entire space as a holistic segment, starting from the ground up to the space, and we would, of course, expect to see our future students, future scientists, give a holistic answer to the issue of space.
I wish I just defer that opinion totally with you, but I want that astronaut to be a female. So girls.
Paradoxically, I would like in the future to go a little bit back to the past in terms of academia in space. It used to be possible for universities to actually build and launch scientific missions, not only technology demonstrations, but actually useful satellites. This sort of died out in recent years because space activity became so expensive that no single university can do that. But now with the new technologies and space activity becoming cheaper again, I hope not only here in Israel, but all over the world, there will be students yourself actually acting and leading space activities in individual universities, and of course collaborating with each other, with people in Israel, but also all over the world. And I think that would be very exciting. So I think it's quite possible that 20 years ago, there will not be one university satellite, there could be hundreds or thousands of them. And this will remove so many limitations in space activity and scientific activity in space that it's really an amazing potential.
Thank you. Neeman?
Yes, being myself a student in the summer space program of the Space University, first I would like to mention how amazing experience it is. And we have here students from all over the world and varied backgrounds, and the interactions that we build here are wonderful. So first I hope that these interactions that we create now will be the basis for future cooperation, really international cooperation in future missions that will include small states like Israel, which have a lot to contribute still. So this is one thing. The other thing I was happy when I got to ISU is to see how many women we have in the program. I think 1/3 of the students are women. And so I hope in 20 years this panel will include at least 1/3 of women, or half or even more. Do I have still, can I still make a point about the Mars mission debate?
Sure, we have time.
Yes. Regarding the Mars mission, and what Israel could contribute, well, a mission to Mars in the future, if it's a human mission to Mars, it's not only about transportation. It's also in the future about surviving on Mars, habitation on Mars, and this requires real international cooperation. And there are areas where I think if we look at the future, and we have to look far ahead, it's areas where we have contributions that we can do from Israel. One example is that we have started discussing here in ISU is 3D printing for space as a way in the future for both for the international space stations, but certainly for missions to Mars, to print things in space. And although it sounds very futuristic, it's a direction of research that we have already started discussing, both with 3D printing companies in Israel, where we have 2 leading companies here, and also we have a lot of research here in Israel about light material that is radar that can be used in space. Combining the two together, finding the right material for 3D printing in space would be a contribution that Israel could do.
Okay. I want to tell one small anecdote.
Please.
I like working with students a lot, with young kids, and there are a lot of high school kids that we work with. And earlier on this year, we had during Space Week, there was a big exhibition in the Tel Aviv Museum where different students were putting on displays. And I went to see what they were doing, and I walked up to a group that was working on Duchifatu, a nano-satellite, high school kids, 9th grade. And I went up to one of the girls, she was 15, and I started asking her questions, and she answered them very nicely, so I started getting more technical, and she said, we've got star trackers on it, what do they do? And she explained star trackers and reaction wheels and solar panels and the radios, and I was giving her the drill. And after 5 minutes, I said, you're really impressive, would you like to come work for me? And she says, I don't know, what do you do? She had no idea who I was. So I said, I'm the general manager of the space division. She says, that sounds like an interesting job, I'd like to do that someday. Come along.
Okay, so with that, before we open for questions from the audience, we want to pay a special tribute to a special person that thanks to him, I think this year we have the largest number of Israeli students on ISU. Ravi, please.
This tribute is to Michael Porter, who is a true friend of Israel and the ISU, as an alum of the first SSP program in 1988, and as a board member of the ISU following the Columbia disaster. Michael sought a way to combine his three passions, space, education, and Israel, while honoring the memory of Ilan Ramon and Columbia mission. He formed the Ilan Ramon Scholarship to help send Israeli participants to the ISU. Over the years, the government funded Ramon Scholarship, supplemented by Michael's personal commitment and private funding effort, increased the number of scholars years after year. Today, many tens of Israeli participants have been supported by the Ilan Ramon Scholarship funded, for which they are sincerely grateful. Likewise, I can say that the Israeli Space Agency is also most grateful for that. Michael's initiative and the persistence over these 10 years has resulted in ever-increasing exposure and participation of the Israel in the ISU. Michael Porter worked quietly away from the spotlight, raising awareness and securing funds to support the scholarship, with an eye on the long-term and positive impact it could have on the Israeli space leadership for years to come. Michael donates his time and money. He takes nothing, asks nothing, but gives everything. Michael, you are more than a friend, you are like a family. On behalf of the Israeli Space Agency, I wish to thank Michael for his effort and his contribution.
Well, thank you so much. It's really heartfelt. It's been a very long journey, and you know, as you mentioned, all the way back to 1988. So the original class of the International Space University, and you know, when Rona did the opening ceremonies, she said that I was a very stubborn, determined person. In some cultures, people might feel a little bit insulted. They might think that comes off as being, you know, too aggressive. But, you know, I took it as a compliment because it's something that I'm really passionate about. ISU changed my life. It was a remarkable experience to be at MIT for a summer in 1988. And just to remind everybody how long ago that was in the middle of the Cold War. We barely got the Soviet delegation to get all the visas to come over. It was almost impossible to get the Chinese delegation to come over. But it made it an amazing event, and had those delegations not been able to come over in 1988, we wouldn't be here today. And even the ISU itself, it's so much like Israel. It's you know, Israel's a startup nation, but ISU is very much a creation of entrepreneurism. So ISU's been around for 30 years, but think about it. Some of the greatest universities in the world have been around for 400 years or 500 years. When people said we have this great idea to do an interdisciplinary university and to make it multicultural, to make it international, people said that's impossible. You can't start. Universities have been around for hundreds of years or for decades. It's impossible to start a new university. And when it was time to contemplate bringing the university to Israel for the summer session, the same sort of story. People said that's impossible. You can't bring ISU to Israel. You know, it makes sense to keep it in Europe, or it makes sense to keep it in Canada, or to keep it in the United States, maybe Asia, maybe China, maybe Japan, but people thought Israel was impossible. But part of that village, part of that journey to bring ISU here, it really was a village. And Ofer, who is probably also possibly a stubborn person with a tremendous amount of determination, he really also helped make that happen. So it's a village. You know, I went around and I had the chutzpah, I shook people down for money, shook people down for a location, for a venue. But it's an amazing community that we've developed here. something that's going to last for years. And most importantly, this idea that, the next great astronaut, Israeli astronaut, will probably be a woman. It is fantastic that we've had so many bright people as part of this program, not just from Israel, but everybody here, just so much talent. And it makes it so much fun to be part of it. So for me, it is a passion to be able to share something that changed my life, ISU, to be part of technology and space. All my passions, all my love in one project. So thank you very much.
Thank you. Michael, I see now why SSP is in Israel. Because first SSP was in 88. First Israeli satellite to be launched was 88 as well. So closing a circle there. So guys, what you see here today is Israel chutzpah. You are part of it because chutzpah is what brought SSP to the Technion. So with that sensation, I would open up for questions from the audience. Who's courageous enough? Yes.
Well, I'm going to start with a big one. So there's been a little bit of discussion here in this panel about the concept of another Israeli astronaut. And this is something I feel is long overdue, considering the fact that, as has been stated before, this is pretty much the Israeli space community. Isn't this a matter of policy, of reaching out to other agencies and creating synergies that will allow Israel to be a part of something like that? So my question is basically, how do you think this kind of thing can happen, and what is possible to do to create this kind of policy? Thank you.
So the question is a big one, and the answer is a short one. Of course, to send an astronaut, it can be only through an international collaboration. Israel doesn't have the capacity to launch astronauts. So last time it was done in collaboration with NASA, with the unfortunate end of that. And if it will happen in the future, and we want that it will happen in the future, it will be once more through a collaboration with the big agencies that have the capacity to do that. Either European, NASA, I would not say with whom we are talking about that, but that will be this is the only way that it can be executed.
So Avi, let's agree that it's not if, it's when.
It's if and when.
When? Okay, next question.
But your wish that to be a woman, it's a good one.
Okay, someone wrote it down? Next question.
Shalom. I'm a physics teacher, and I know that most physics teachers are over 50 years old. And if you're talking about Israel research for the next 15 years, most of them won't be teaching anymore in 15 years from now, and they don't really have replacement. So do you think the industry can cope with a lack of proper education in the schools, or can the schools overcome the problems somehow?
So that's an excellent question.
Now? Okay. So that's an excellent question, and it's a very important topic. And indeed, our community of physics teachers is getting old, and they are approaching, or some of them are already retiring. And at least I can tell you about efforts that are being done at the Weizmann Institute. This constitutes two parallel efforts. One effort that we've started started in Tel Aviv some years ago and is now also being set up in the area of the Weizmann Institute in Rehovot, is to create centralized schools to teach physics to large geographical areas, so that with the smaller communities of available physics teachers, you can serve a larger community. Because and the way it used to be that you have an isolated physics teacher, in maybe a single teacher in a very large school, that person certainly has a large, it's a difficult situation. He has no community, he has no peers to work with. So this is a partial solution for that. In that sense, it's also then easier to fund and construct better facilities like laboratories or even classrooms that are modeled to be optimized for science teaching and physics teaching in particular. And the second big effort that we are doing is to, one of the missions of the Weizmann Institute is to bring science to the public. And it's actually very difficult to do it child by child or person by person because there are so many people. The teachers are really the key to that, because if you reach out to a single teacher, over several years that person will educate hundreds of kids. So doing the program for maybe 100 teachers, which is possible, you can, by multiplication, reach the entire high school population of Israel. So there are several programs aimed at physics teachers, either existing teachers or introducing new teachers to the system, whether recruited from the industry. There are projects using the internet. For example, we found that many people with physics education that do not work as teachers, they work in the industry, they work even in the military, some places like that. They are willing to contribute some percent of the time. So if you allow them, let's say, to teach remotely, maybe even 1 hour a week or 2 hours a week, they can contribute. So each one of them contributes a small amount of help to a physics teacher in a class, but together it constitutes a large community. So that's certainly a focus, and I agree that we need to think differently. Just trying to recruit physics teachers the way we used to do it. Of course we need to do that, but we also need to enhance it so that every physics teacher that we have can use optimize his potential to reach out for as many kids as we can.
Thank you. Anyone else, or we move back to the... Okay. More questions?
Hello, thank you all for coming. My question is, there's been a lot of talk about the need for international collaboration. Is there a possibility for, or if there is, what is the implication of collaboration with other Middle Eastern countries? And if that's possible, and especially what are the implications of it?
We collaborate with them all the time in satellite imaging. We image them.
As for scientific mission, it might be in the future. I don't think that currently Middle East countries are joining international collaboration in science besides Israel, but in the future, if they will, of course, not. I don't see any restrictions to that.
No, not in space, but if you look at Jordan, for example, you talk about Middle East, we have, I think, some mutual scientific works with Jordan on bird migration, whatever. No, but this is a basic. If you have a possibility to collaborate with your neighbors on non-space, so space is just a step ahead. That's what I'm saying.
Already existing scientific. There are existing scientific collaboration with the Middle East, other Middle East countries, which are in peace with Israel. In space, they are not already over there, but as we're doing in other areas, it can be done also in space.
One thing that we can think about, which relates to a question that we already conducts is looking at remote sensing of the ground for example, for agriculture, for desert processes. That's of course, it's a big issue for Israel, but it's also a big issue for other nearby countries. And if you have a satellite that is looking on this area from above, the same sort of data will be useful for everybody.
Actually, there was a project that I don't think many people are familiar with. It was a project to use the Agnes, the Moderator augmentation system of the GPS to get the accuracies. It was a joint project between Israel, the Palestinian Authority, Tunisia, Algeria, and Egypt. And it was managed by the Technion a few years ago. So it's an example that people that are interested in doing science together can do it no matter where they're located, whether it's the Middle East or somewhere else. So I don't think it should be a problem to do that.
Thank you. Lily?
In the same direction that Avishai started, there is a cooperation going on with Jordan on water areas, on the Mediterranean pollution issues with Egypt. So all these kind of cooperation are using satellite imagery. So this is cooperation in space.
I think we have time for one more question. Please.
So I was just wondering, I know that there's a lot of problems with BDS and other different boycotts against Israel, and there are a lot of teachers and educational facilities that refuse to cooperate with Israel. I want to know if, in your opinion, that affects the space program at all, if BDS or any other boycott, education boycott, and affects the work that you guys are doing or will be doing, or something to that effect.
So I'll give you a different answer that will blow your mind away. The UN has been negative on Israel for over 20 years. There was probably not even a single positive resolution supporting Israel for the past 20 years, beside one. This year, we were admitted to UN caucus with a huge majority. That was like 70 supporting and about 5.
Eventually the voting, 122.
Here you go. 122 countries supported the inclusion of Israel in UN caucus with negligible countries against. So when it comes to real decisions based on facts and based on merits and achievements, those boycotters, they cannot stand to it because they have no claim, no true claim. So truth will prevail.
I will add to that I think a symbol for that success of Israel is the fact that Israel hosted the IAC in Jerusalem 6 months ago. That's the most important, largest annual space conference. So I think that says it all. So with that, I want to conclude and thank all of our speakers tonight: Ofer Lapid, Ofer Doron, Avi Blacksberger, Alma Morar, Tini Birkin, Avishai Galyan, and Neeman. Thank you and good night. תודה רבה.